Hello everyone. This is a new series I started on FPGA. I'm using edX Artix-7 development board for this entire series of FPGA. In this series, we are going to see from scratch to making a project using the FPGA board. Why we need to go for FPGA? Many of us already started using microcontroller. In that, what we have observed is in microcontroller, we know that the execution structure is sequential or it will execute line by line. What the problem with execution of line by line is, if you want to do some parallel operation, usually in the microcontroller, we will use a priority based like uh, like interrupts, and that interrupts also again priority based. For example, a reset is the high priority, and next other priorities based on the different microcontrollers. The priority based we will do, and then once the priority based task is completed, again the main task will be continued. So this will not execute in the faster way, whereas in the FPGA, the hardware what we are programming is executed in the parallel. It means that we don't want to worry about the priority and other things. Directly, parallelly, simultaneously, we can operate multiple operations or logics simultaneously. This will increase the speed as well as this will useful for the real-time application where more precise time is more precise. And as we already discussed that microcontroller FPGA is a microcontroller is the sequential execution and the FPGA is the parallel. And one more thing is, if you see the flexibility, microcontroller is not more flexible because the peripherals used in the microcontrollers are fixed. Like example, UART and analog to digital converter, pulse width modulation pins, where it is the fixed one in the microcontroller. But in FPGA, we can customize what we need exactly for our application. For example, we can create our own UART circuit in the FPGA board by writing a proper code for that, as well as in the pulse width modulation, especially for any power electronics application or any other devices. And if you see the coding, what we are using in the microcontroller is a simple code that we will write in the C, for example, in the Arduino, whereas in FPGA, we need to write a hardware design type of codes using Verilog or VHDL. And if you see the applications from the microcontroller, it's a simple controller and IoT automations we can use microcontroller, where if you need a high speed processing like a DSP or customized logics you want for advanced research, we'll go for FPGA. And the program flow for implementing the FPGA project is first we need to write HDL code using Verilog or VHDL, and we need to build the constraints. The constraints is nothing but the FPGA board is open-ended, like we can modify the pin in the hardware level. So we need to constrain based on the core FPGA what we are using. In that we can do our custom constraints based on the custom constraints in .xdc file. I will explain what is this .xdc later while in the next video while explaining the software what we are going to use. So first we need to create the constraints and then we need to write the program. And later, once the constraint program is ready from the Verilog, then we need to synthesize the code what we have written in the Verilog. What is synthesize is nothing but it converts your Verilog code, HDL code into logic gates, actual logic gates. Once the logic gates is created, then we need to implement. Implement stage is nothing but we need to place and route those logic gates into FPGA, that is in the actual hardware blocks like flip-flops and LUTs. Once implementation is done, then we need to generate the bitstream. Bitstream is the file finally we are going to dump into the FPGA board. So we need to finally create or generate the bit streams. If the bit stream is ready, then we are ready to program. and we need to program the FPGA, and later we can see the hardware. All these things in upcoming videos we are going to see in hands-on very practically, and you come to know what I mean in the upcoming videos. And what software we are going to use to execute all this flow, as I said, like write, constrain, synthesize, and program C, we are going to use Xilinx Vivado. So this Xilinx Vivado is very similar to any other integrated development environment or IDE we are using for microcontroller. For example, many of you have already used Arduino. So they have provided Arduino IDE, that is integrated development environment. Whereas this Vivado Design Studio is given by Xilinx official tool for programming FPGA and SoC. It contains IDE as well as the electronic design automation tool. It's combined of these two, which provides code editor, synthesize, implementation tool, constraint edition, and we can able to simulate before dumping our Bitstream file into the FPGA. We can simulate and test your logics, and then finally we can generate the Bitstream, as well as this software help us to dump our program to the FPGA board. And what core we are using for this Edge Artix-7 development board, as shown in the image, you can see the corner, right corner, you can see the board which is displayed, live display is going on. So it is based on Artix-7 FPGA. The version or the FPGA board IC number is XC7A35T-1FTG256. This board has onboard clock of 50 megahertz. Some other board has 100 megahertz also. But what I'm using for this tutorial is 50 megahertz. It has inbuilt or onboard 20 plus switches and 17 LED active low. And it has one 7 segment VGA, HDMI, UART, and inbuilt USB, Bluetooth, and Wi-Fi. So with this board, we can do mid-range to high range of projects, real-time projects with this development board. And it has ADC header, buzzer, and TFT display and camera connector. So if you want to do some image processing, we can use this board for doing it. And this board is ideal for FPGA learning, digital design, and embedded hardware projects and protocols. And you can also see the block diagram, which is represented here. It has how the voltage variation of logic voltage power in, which has 1.1 voltage and 1.8 volt and 3.3 volt logics. We can use either one of that. And the detailed data sheet for the FPGA IC chip what we are using is given in the description. You can go and download and check for more detail if you want to go detail to understand this IC. And in next video, we will jump into the actual project by seeing the software what we are going to use to program this FPGA. See you in the next video. Bye.